Cardiovascular effects of exercise. In this lab, you will record the electrocardiogram, ECG, and the finger pulse of a healthy volunteer. Then you will compare the recordings made while the volunteer is at rest and immediately after exercise. We will be using the PowerLab 15T by AD Instruments, and the software we'll be using is LabStation. ECG and pulse equipment setup. Make sure the PowerLab is turned on. Connect the electrode lead wires to the bioamp cable. Connect the bioamp cable to the bioamp input on the PowerLab. Connect the pulse transducer to input 1 on the PowerLab. ECG and pulse electrode placement. Remove any watch and/or jewelry from the volunteer's wrist and ankles. Mark each point where the electrodes will be placed, on both wrists and on the right leg. Lightly abrade the skin at these areas with abrasive gels. Then clean the area with alcohol swabs. Snap the ECG leads onto the disposable electrodes. Attach electrodes to the prepared areas of the volunteer's skin. Attach the positive lead to the left wrist. Attach the negative lead to the right wrist. Attach the ground lead wire to the right leg. Attach the pulse transducer to the volunteer's middle finger. Placement of electrodes is as shown. Attach electrodes as well as the pulse meter as indicated before. Have the patient sit calmly with their feet on the floor and their arms resting on the table. Then begin the trace. Allow the program to run until 6 to 10 good clean traces have been recorded. Then hit stop. So initially we want to calculate the beats per minute using the lower pulse window. So you can ignore the ECG at the top. And what we want to do is we want to use our bracket tool. So we can click on that. It's at the bottom. It will present us with 2 brackets. And what we want to do is move one bracket to the crest of one of the pulse waves. We're going to move the other bracket to the crest of the adjacent pulse wave. Next, we want to scroll down and look at the time signatures at the bottom. And you might need to zoom in using this plus or minus tool. So we're going to zoom in right here and scroll over so we can see the starting time as well as the ending time duration between those beats. So we have an ending time of 4.6, and in a second we'll scroll back and see the starting time, which was 3.6, and from there we can calculate the final time minus the initial time. So 4.6 minus 3.6 gives us 1 second duration for that beat. So now I've just zoomed out and I'm going to adjust my bracket tool to the next adjacent pulse wave and repeat the process of measuring the duration. We want to do that for a total of 3 pulse waves in a row. Now we're going to briefly look at the math used to calculate the duration of one heartbeat. We're going to subtract the initial time from the final time, and that will give us the duration of one beat. Next, we'll divide 60 seconds per minute by the duration of one beat. This will give us the beats per minute. Finally, we'll determine the average beats per minute using the pulse method by adding up the beats per minute and then dividing them by 3. So now I'm going to be using the ECG signal to determine the average heart rate. And what I'm doing is I'm setting the markers from R peak to the adjacent R peak in measuring the duration. Sometimes with this, to get quite accurate, you're going to need to adjust the scale for the time. As you can see, I've been doing and scrolling back and forth. But essentially, we're going to measure 3 R peaks in a row and take the average, just like we did with the pulse meter. We're going to look at the math now. So just as we did in the pulse method, we're going to subtract the initial time from the final time, and that will give us the time in seconds per beat. So once again, to determine the beats per minute, we're going to divide 60 seconds per minute by the duration of 1 beat. And then finally, we're going to take the summation of each one of those beats per minute and then divide it by 3, and this will give us the average beats per minute using the ECG method. So next, we're going to look at the trace soon, and we're going to determine the length of the PR intervals for 3 consecutive traces. There's a fair amount of artifact or distortion on the actual trace, so I'm showing you this now, and then I'm just going to show 1 PR interval, and then I'll give you the data that I collected for 3. As I mentioned before, on the actual trace, there tends to be a fair amount of artifact or distortion in this PR interval region. So in the interest of time, I have used the bracket tool just like we did before, and I've bracketed 1 PR. Remember, we're going to do that 3 consecutive times. I'm just going to show you 1, and then I'll give you the data that I've collected for the other 2. So here's the data for the 3 consecutive PR intervals. 0.11 seconds for the first, 0.12 seconds for the second, and 0.11 seconds again for interval number 3. Next, I'll be measuring the QRS interval on 3 consecutive traces. So the QRS intervals value are as follows. Interval number 1, 0.06 seconds. Interval number 2, 0.06 seconds. And interval 3, 0.05 seconds. Next, I'm going to be measuring the QT interval, which stretches from the point of Q all the way to the end of the T wave. Once again, I'm using the bracket tool, and I'm placing 1 point on Q and the other at the end of the T wave. The data for the 3 consecutive QT intervals I collected are as follows. QT interval number 1, 0.38 seconds, number 2, 0.34 seconds, and number 3, 0.37 seconds. Next, I'll be measuring 3 consecutive TP intervals, which spans the time from the end of 1 T wave to the beginning of the P wave in the following trace. The data for the 3 consecutive TP intervals is 0.63 seconds for the first, 0.55 seconds for the second, and 0.50 seconds for the third. So now I'm going to study the effects that holding my breath has on my heart rate. So I'm going to again start in the rested position, relaxed, feet completely on the floor, no movement, and I also want to be careful that when I start holding my breath, I don't clench my neck muscles as this could skew the results. When analyzing the data, I will be using the waveforms in measuring and averaging the heart rate immediately after holding my breath. So I was able to hold my breath for about 41 seconds, and now I'm going to use the R method like we did at the starting of the video to calculate the beats per minute. Now we're going to take a look at the effects of exercise on the heart rate as well as the interval durations. So you can see I'm taking off the leads for the electrodes as well as the pulse meter. I'm going to go outside and exercise for about 3 minutes straight and then come back in and hook everything up and start taking the readings. So now that I've worked out for about 3 minutes straight, I'm going to attach the electrodes as well as the pulse meter, and we're going to start taking some measurements. And then I'm going to go through and measure average heart rate as well as the interval durations for each of the waves we measured during the resting phase. Now that I have a post-exercise trace recorded, I'm going to use the methods that we employed earlier to determine the average heart rate, PQ, QRS, QT, and TP intervals. I will then present them in a data table comparing them to the resting values recorded earlier.